Welcome to the second term evaluation of 2018 for grade 6 Maths Western Province, part 2. So they're asking us to answer the first question and another 4 questions only, but I'll be discussing all 7. First question carries 16 marks and other questions carry 11 marks each. So basically 11 into 4, 44 plus the 16, you get 60 marks in total for part 2. Use a separate paper to answer the question, so I'm using a separate paper here. Question number 1. Recollect your knowledge on odd numbers, even numbers, prime numbers, composite numbers, square numbers, and triangular numbers, which was discussed in the lessons Numbers and Number Patterns. Part A. The following figure shows how Nimal represented the first 4 stages of a number pattern using dots. So here we have the first pattern with 1 dot. We'll write the number down, 1 dot. Second pattern we have 4 dots. Third pattern we have 3 to 3, 9 dots. And the fourth pattern we have 4 times 4, 16 dots. And when you look at these patterns, the shape that comes to mind is a square shape in each case. You have a square shape. Even here, even though it's just 1 dot, we can consider it as 1 times 1 as 1. Here 2 times 2 as 4, 3 times 3 as 9, 4 times 4 is 16. Right. Part 1. According to the above pattern, represent the 5th stage of the pattern using dots. So when you look at it, you get the idea. The 5th pattern will have 5 columns and 5 rows. 5 columns and 5 rows. Columns are this way and rows are sideways. Columns are vertical and rows are horizontal. Right. So if you go 5 by 5, put part 1 here. It will be 5 dots is 1 column. So like that 5 columns. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It will look something like that. Question number 2. Part 2. Actually, write the number of dots in the first 5 stages in order. Right. So first one has 1 dot. 1. Second one has 2 times 2, 4 dots. Third one has 3 by 3, 9 dots. Fourth one has 4 by 4, 16 dots. And the last one, what we just drew, has 5 times 5, 25 dots. Right. Question number 3. Which number pattern is represented by the above numbers? So, remember in the beginning I said, the shape that comes to mind when we look at it is a square shape. And we get that because the number of columns and the number of rows in each stage are the same. Now for example, if you take the first stage, 1 row, 1 column. Second stage, 2 columns and 2 rows. Third stage, 3 columns, 3 rows. Fourth stage, 4 columns, 4 rows, and so on. So these stages create the square shape, and the number of dots are members of the square number pattern. So we can write the answer as square numbers. Square, square numbers. Right. Part 4. What is the 9th term of it? So now it's very important to read the question carefully. They are not asking us to draw it, they are just asking us to give the 9th term. So the 9th term you get by multiplying 9 by 9, which is 81. So 81 is the 9th term. Part 5. Which term of it is 144? Right. So we know that if there are 144 dots in the square, right, the stage or with the term that is that one will be the square root of it. For example, now when we have 16 dots, the square root of 16 is 4, and 4 is the number of that stage. This is the fourth one. Here we have 9 dots, square root of 9 is 3. This is the third pattern, third stage of the pattern. Here we have 4 dots, square root of 4 is 2. This is the second one. Here 1, square root of 1 is 1. Like that, we have to know which number square root of 144 is the answer there. Square root of now 144 is 12, because 12 times 12 is 144. So 12 is the answer. Right. This is part A, question 1. Then we go to part B. Part B, one plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 equals 28. The seventh term of the triangular number pattern can be obtained as mentioned above. So subpart 1 in part B. What is the eighth triangular number? So the eighth triangular number, we have to add 8 to this pattern here, this seventh term actually. So that will be 28 plus 8, which is 36. 28 plus 8. Right. Subpart 2. Which triangular number is 55? Right. So the eighth one is 36. So if I add 9 to that, I get the ninth one, which is 9 plus 36, 45. If I add 10 to that, you get the 10th one, which is 55. And they're asking which triangular number is 55. So that's the 10th one. 10th triangular number. Question number 3. Write all the prime numbers between 10 and 20. Right. So let's consider. Can we include 10? 10 and 20 are definitely anyway not prime numbers. They are divisible by 2. 11? Yes, 11 is a prime number. 12 is not a prime number. Basically, 2 is the only even prime number, so we can eliminate all the even numbers between 10 and 20. 12 won't come, 14 won't come, 16, 18, even 10 and 20 we cannot consider because they are even numbers. Even numbers cannot be prime, only 2 except for 2. So 10 is not a prime number, 11 is a prime number. 12 is not a prime number, 13 is a prime number. 14 is not a prime number, 15 is divisible by 5 as well as 3, so it's also not a prime number. 16 is not a prime number. 17, that's a prime number. 18 is even, so it's not a prime number. 19 is a prime number. And 20. So 11, 13, 17 and 19. So we are done with question number 2. We got 16 marks for that. Now moving on to question number, we are done with question number 1 and we get 16 marks for that. Now we move on to question number 2. Right. Question number 2. Simplify. Part 1. So very basic mathematical operations. Here we have 4,987 plus 92. Let's add and see what we get. 7 plus 2 is 9. 8 plus 9 is 17, 1 remainder. 1 plus 9, 10, 1 remainder. 1 plus 4, 5. 5,079 is the answer for part 1. Right. Part 2. 9,000 minus 376. Write 9,000. Write 376 below that. Subtract. See, 0 minus 6 we cannot do. Borrow 1. 10 minus 6 is 4. Now here is 9. 9 minus 7 is 2. Here it's 9. 9 minus 3 is 6. And here we gave 1, 8. 8, 6, 2, 4. Can add back and check if it's correct. 4 plus 6, 10, 1 remainder. 1 plus 7, 8, 8 plus 2, 10, 0, 1 remainder. 3 plus 1, 4, 4 plus 6, 10, 0, 1 remainder. 8 plus 1, 9. Question number 3. 430 multiplied by 10, so very easy. You just add a 0 to the end of 430, it becomes 4,300. So this is a very basic question, so I would recommend you to choose this. Next one, part 4, 35,000 divided by 100. So 100 has 2 zeros. Cut off 2 zeros from 35,000, we get 350 as the answer. 350 as the answer. There's 2 zeros, just cut off these 2 zeros, we get 350. Right. Part 5, sorry. Question is 854 multiplied by 37. It's a bit harder. 854 multiplied by 37. So write it like this. Then we multiply. 7 times 4, 28, 2 remainder. 7 times 5, 35 plus 2, 37, 3 remainder. 7 times 8, 56 plus 3, 59. Then 3 times 4, 12, 1 remainder. 3 times 5, 15 plus 1, 16, 1 remainder. 3 times 8, 24, 24 plus 1, 25. 8, 9, 15, 1, 6, 11, 1, 3. 31,598 is the answer. Question number 6. 839 divided by 10. So very easy. We are dividing by 10. Just move the decimal place to the left by 1. So this one comes here. We get here 83.9 as the answer. We easily get 11 marks there. They are asking for, can leave it like this, or we can say the quotient. Quotient is 83 and the remainder is 9. Right. Moving on to question number 3. Question number 3, they have given us a straight line segment and said a straight line segment used to represent numbers is called a number line, right? So this is a number line. Question number 3, part 1, write 3 characteristics of a number line which was drawn correctly. Right. So what are 3 characteristics? We can say the distance between 2 consecutive numbers. Consecutive numbers are numbers which are next to each other. So for example, 0 and 1, 1 and 2, 2 and 3. Right? If you draw it correctly, this distance, the distance between 2 and 3 should be the same distance between 0 and 1. So we can say the distance between any two consecutive numbers is the same. Next, we can say that at any one point of the number line, only one value is given. So here it's 0, there's nothing else, just 0. So only one value is denoted by 1 point on a number line. And finally, we can also say that when you go towards the right of the number line, the values are increasing. So for example, we start with 0. If I go to the right, it becomes 1, 2, 3, so on. As you keep going to the right, values are increasing, or if you go to the left, that means the values are decreasing. So value of numbers increase when going towards the right of a number line. Right. Now let's go to part 2. Part 2, they're saying draw a number line correctly and mark 0, -3, 3 and -1 on it. So I can do that. Take a ruler . This is part 2, and now we have to draw 0, -3, 3 and 1, -1 on it, right? So remember, if I take -3 here, -2, -1, 0, 1, 2, 3. -3, -2, -1, 0, 1, 2, 3. Yeah. So we have drawn, and they're asking us to mark 0. So 0 is marked, -3, -3 also marked, +3, that's also marked, -1 also marked. Right. Question number 3, subpart 3 actually. Write the integers 0, negative 3, 3 and negative 1 in ascending order. So ascending means lowest to highest. Now we have marked all 4. So let's see what's the lowest one, negative 3. Then the next one is negative 1. Then 0. And finally positive 3. Part 4. Use the inequality signs less than or greater than correctly and fill in the blanks. Part A. Negative 7 blank 3. So negative 7 will be somewhere here, positive 3 is here. So when you're comparing two numbers, the number on the right side is always greater, because we learned that one of the points is as we go to the right, the numbers increases. So if I mark negative 7 on the number line, it will come somewhere here. Positive 3 is already here. So the one on the right is the larger one. So the mouth will be open towards that side, less than negative 3, right? Part B, 0 and negative 8. Right. So 0 is here, negative 8 will be somewhere here. So again 0 is here, we have the larger number is on the right, negative 8 is here. Negative 8 is here, 0 is here, which is on the right? 0 is on the right, so 0 is the larger one, the mouth is open towards 0. Here we have the greater than sign. And finally part C, negative 5 and negative 9. Right. So here negative 5 and negative 9. Negative 5 will be somewhere here and negative 9 will be somewhere here. Negative 9 somewhere here, negative 5 somewhere here. So what is on the right side? Negative 5 is on the right side. That's the larger one. So the mouth is open towards that. That's the larger one. Question 4. 3 is done. Now go to question number 4. Question number 4. Part 1. Write down the fraction with denominator 10 and numerator 3. So it's very easy. Numerator 3, denominator 10. 3 upon 10. Part 2. Write down the unit fraction with denominator 5. Unit fraction means the fraction where the numerator is 1 and they are given the denominator is 5. 1 upon 5. Question number 3. Part 3 actually. Write an equivalent fraction for the unit fraction written in part 2. So I have written 1 upon 5. To get an equivalent fraction, what I should do is I should multiply the numerator and the denominator both by the same number. So I can easily multiply up and down both by 2. If I multiply up and down both by 2, 1 multiplied by 2 is 2, 5 multiplied by 2 is 10, 2 upon 10. Part 4. Find the value of five upon 13 plus 2 upon 13 plus 4 upon 13. So 5 upon 13 plus 2 upon 13 plus 4 upon 13. So to add fractions, we should make sure that the denominators are the same. Here all are 13s, all are same. At the top, 5 plus 2, 7, 7 plus 4, 11, 11 upon 13. Right. Question number 4. Find the value of 7 upon 8 minus 1 upon 4. Sorry, part 5 actually. 7 upon 8 minus 1 upon 4. So here the denominators are different. So I have to make the denominators the same. I can take the lowest common multiple of 8 and 4, which is 8. I can convert both denominators to 8. Here it's already 8, so I write 7 upon 8 minus. If I make this denominator 8, I do that by multiplying this by 4. 4 times 2 is 8. So I do the same thing to the numerator. 1 times 2 is 2. Now I get 7 minus 2, which is 5. 5 upon 8. Part 6. Sum of two unit fractions is 8 upon 15. Sum of two unit fractions is 8 upon 15. Write down the two unit fractions. So unit fractions are 1 upon something plus another 1 upon something is 8 upon 15. Right. Unit fractions, again, like we did earlier, here we did the unit fraction 1 upon 5. Right. So 1 upon something plus 1 upon another something is 8 upon 15. So let's see. When I add unit fractions, what I do is I get the LCM of the numerator and the denominator. Sorry, the LCM of the two denominators. So whatever this denominator is and whatever this denominator is, if I multiply with each other, I should get 15. So the factors of 15 are 15, you can write as 1 times 15, and you can also write as 3 times 5. So it won't be 1 and 15 because 1 upon 1 is just 1. I'll take 3 and 5. So if I write 3 and 5, now let's see. 5 times 3 is 15. Here it will become, I have to multiply this by 5 to get 15. So top by 5 I get 5. Multiply this by 3 to get 15. Top by 3 is 3. 5 plus 3, 8. 50. 8 over 15. So these are the two unit fractions. 1 upon 3 and 1 upon 5. Fractions are 1 upon 3 and 1 upon 5. Question number 5. A. If the following statements are true, put a tick, and if they are wrong, put a cross in the brackets. Part A. Subpart A. This is a quadrilateral. Quadrilateral will have 4 sides. Let's count and see how many sides this shape has. 1, 2, 1, 2, 3, 4. 4 sides. Correct. It's a quadrilateral. Part B. This is a closed figure. A closed figure will have no openings. This one has an opening here, see? It's not a closed figure. So it's wrong. Cross. Part C. In a rectangle, all the angles are equal. Let's say this is a rectangle. Here, this angle is 90. This is 90, this is 90, and this is 90. Yes, all are equal. All are 90. Correct. Tick. Part D. This is a straight angle. Straight angle will be something like this. Flat. 180 degrees. This is not flat here. There's a bit of an angle here. This is not a straight angle. It's wrong. Not straight angle. Part E. In a parallelogram, all the sides are equal. Wrong. All the sides are not equal. See, this length and this length are not equal. Doesn't have to be. It's wrong. Right. Part B. Subpart 1. Perimeter of a square is 48 centimeters. What is the length of a side of it? Right. So part B. Question 5. Part B. Subpart 1. Perimeter of a square is 48 cm. The square, say x. So square, all the lengths are equal. So there are 4 x's. 4x is equal to 48. So x is equal to 48 divided by 4, 12. So length is 12 cm. Subpart 2. If the length and breadth of a rectangle is 70 cm and 30 cm respectively, find the perimeter of it. Right. So the length is 17 cm. The breadth is 13 cm. Get the perimeter. So this was the 13 and this is 17. So to get the perimeter, you can add the length and the breadth and multiply it by 2 because there are 2 lengths and 2 breadths. So perimeter is equal to length plus breadth multiplied by 2. 2 times 17 plus 13 is 30. 60. So the perimeter is 60 centimeters. Sub part 3. Find the perimeter of the given figure. Right. So this one, we don't know this length and we don't know this length. But we know that this one plus this one together will give you 18. Right? So we can consider this plus this as, I'm calling this 1, or we can call this A and B. Right? A plus B we can take it as 18. Because this length and this length is equal to this length. At the same time, so 18. A plus B is 18. This plus this. At the same time, this length and this length combined will give you 7. So C and D, let's say, even though I don't know individually what they are, together I know they add up to 7. So C plus D is 7. Right. Also, we have this 7 and this 18. So another 7 and another 18 is there. This 18 is here, this 7 is here, C plus D is 7 and A plus B is 18. So altogether the perimeter is 18 plus 18 plus 7 plus 7. So when you add this, 8, 8, 16, 23, 30, 3 remainder. 3 plus 1, 4, 4 plus 1, 5, 50 cm. Or we can do 7 plus 8, 15, 8, 7 plus 18, that's 25, into 2, which is 50. Either way you get the same answer. So the answer for this one is part 3, 50 cm. Right. Question number 6. Part 1. 118.0. Write the number. 118.0. Sorry. Yeah, 118.03. Actually, there's a mistake here. It should be 03. 118.118.03. 118.03. Part 2. Write the number represented in the abacus in numerical form. So let's see. Tens place, there are 2 of those. So this is 20. Ones place, there's 1. 1/10, there's 1. There's 2. Sorry, ones place, there are 4. 1, 2, 3, 4. So 4 here. 1/10, there are 2. So that's 0.2. And 100, there are 3. That's 0.03. So altogether, 20. Here 2 tens, 20. 4 ones, 4. 2 0.1s, that's 0.2. And 3 0.01s is 0.03. Now we can add 3, 2, 4, 24.23. So the answer is 24.23. Question number 3. Write it in words. .23, not 23. 23. Right. Question number 6, part 4. Write 3 upon 10 and 7 upon 100 as decimal numbers. So 3 upon 10. You can write 3 and there's 1 0 means 1 decimal place, 0.3. 7 upon 100, that is 7, but there are 2 decimal places here. So 0.07. 2 zeros, 2 decimal places. 1 0, 1 decimal place. Question number sorry, part 5. Write the value of 53.7 minus 8.98. 53.7 minus 8.98. Sorry, I didn't write that correctly. 53.7 minus 8.98. So I can put a 0 here and subtract. 0 minus 8 I can't do, borrow 1. 10 minus 8 is 2. Now here 7, since I borrowed, gave 1, it becomes 6. 6 minus 9 we can't do, borrow 1. 16 minus 9 is 7. Now I gave 1 here, so it becomes 2. From 2 I can't deduct 8, borrow 1. 12 minus 8 is 4. I gave 1 here, so it's 4. 44.72. Add and see. 2 plus 8, 10, 1 remainder. 1 plus 9, 10, 10 plus 7, 17, 1 remainder. 1 plus 8, 9, 9 plus 4, 13, 1 remainder, 4 plus 1, 5. Yeah, 44.72 is the answer. Moving on to the final question, question number 7. 28 is equal to 1 times 28. And 28 is equal to 2 times blank, and 28 is equal to 4 times blank. So complete the following statements using suitable numbers for the blanks. This is easy. Just do, to get this one you have to divide 28 by 2. Do the long division, you get 40. And here 28 by 4. So 28 by 4 you get 7. Now you can check 4 times 7, 28 correct. 2 times 14, 28 correct. Question number 2. Write all the factors of 28. So we can write 1, 2, 4 and 4 times 7, 2 times 14 and 1 times 28. These are all the factors. Same as this. Is 9 a factor of 28? Give reasons for your answer. If you divide 28 by 9, what happens? You get a remainder. Because 27 can be divided by 9. 27 divided by 9 is 3. If you divide 28 by 9, we get 3 and remainder 1. So the answer is no. 28 is not divisible by 9 exactly. Question part 4. 357 blank given 4-digit number is divisible by 5. What are the digits that should be in the blank box? So if a number is divisible by 5, the requirement for a number to be divisible by 5. What are the requirements? If you take the 5 times table, see what are the multiples of 5? 5 times 1 is 5. 5 times 2 is 10, 15, 20, 25, 30 and so on. So you see, if it's divisible by 5, the last digit is either 5 or 0. So either 5 or 0. 5 or 0. So the possible answers are 0 or 5. Price of a part 5. Price of a coconut is 70 rupees. Find the price of 6 coconuts. So that's very easy. If one coconut is 70 rupees and you want to get the price of 6 coconuts, just multiply by 6. 6 times 0, 0. 6 times 7, 42. So the answer for this one is rupees 420.